Hey guys, what are you doing?
We're trying to find a triple point.
The triple point? What's that?
The triple point is the temperature and pressure at which all three phases of a substance coexist in equilibrium.
Here, take a look at this pressure-temperature graph. The triple point can be identified as the intersection of the sublimation curve, the melting curve, and the vaporization curve.
So, what chemical you will use?
We'll be using T-butanol. T-butanol is a tertiary alcohol, and it's convenient because its temperature and pressure at the triple point can be measured easily in the lab.
Although it's perfect for demonstrating the triple point, it's extremely flammable and should be used with caution. It should not be exposed to any open flames or extreme heat.
That's right. Its flash point is only 11 degrees Celsius, which means that at normal conditions, this chemical forms an ignitable vapor. As an extra precaution, we'll perform this experiment in a well-ventilated hood to prevent vapors from accumulating in the lab.
Could you show us the apparatus you will use?
Sure, let's check it out. The butanol is placed in a stoppered flask, which sits in a water bath. The stopper is fitted with a condenser and a thermometer. Cold water running through the condenser will cool and condense any T-butanol vapor that results from heating.
The top of the condenser is attached to another flask called the trap flask. The trap flask is also attached to a manometer and to a pump. These attachments serve to expose the process to a pressure gradient induced by the pump.
Oh, I see. So the trap flask is there just in case mercury is suctioned from the manometer.
Exactly. There is also a relief valve between the trap flask and the pump in case the suction is too high and the pressure must be restored.
All right, guys, are you ready to run the experiment?
Yes, let's first make sure that all tubings and stoppers are secure. Now we'll turn on the cold water for the condenser.
Now we can go ahead and begin changing the temperature and pressure of the system. The flask containing T-butanol is exposed to a hot water bath so that its temperature is increased to approximately 30 degrees Celsius.
At the same time, you will begin steadily decreasing the pressure until we approximately reach 28 inches mercury. While changing the pressure and temperature of the system, we wait and watch carefully for the triple point to occur.
We've reached the triple point. See the bubbles in the crystal formation? The liquid T-butanol is boiling and freezing at the same time. Let's read the temperature and pressure. Let's see. It looks like the temperature is somewhere between 25 and 25.5 degrees Celsius, and the pressure is 22.8 inches mercury.
Wait, so is there only one possible temperature and pressure for a triple point?
Yes, remember Gibbs' phase rule? Degrees of freedom is equal to the number of chemical components minus the number of phases plus 2. There are 3 phases, solid, liquid, and gas, and there's one chemical component, T-butanol. That means that the degrees of freedom is 0 and the problem is fully specified.
That's why it's called a triple point and not a triple area or triple curve. However, different substances will have different triple points.
So you found the triple point of T-butanol to be around 25 degrees Celsius and 23 inches of mercury, but how do we know whether that is correct or not?
Yeah, what if you read the measurement wrong, or what if your equipment is faulty?
Well, according to the literature, the triple point temperature is between 25 and 26 degrees Celsius, and the triple point pressure is between 22 and 24 inches mercury. This happens to be consistent with what we found in our experiment, but it's always best to test the results of others. Now that you know how to do it, you too can try the experiment for yourselves.
Yeah, we'll try. This presentation was brought to you by Alshayeb,
Chelsea Kreutz,
Krista Wright,
Micah Steele, and
Mohammed Al-Somali.
Thank you.